Hey everyone, and welcome. Today, we're diving headfirst into a topic that's absolutely critical if you're running modern, complex applications: observability. We are going to pry open that black box your system can feel like and give you a really clear, step-by-step guide to understanding what's really going on under the hood.
So if you're a DevOps engineer, an SRE, or really any developer today, this question, it probably hits a little too close to home, right? An alert goes off, latency is spiking, customers are starting to notice, and boom, it's that frantic scramble to find the root cause. It's that stressful all-hands-on-deck moment that, let's be honest, we'd all love to avoid.
And, the reason it's so stressful is because our systems today, they're just ridiculously complex. We're talking microservices, Kubernetes. A single click from a user might ripple through dozens of different services. So when something breaks, it's not obvious where to even start looking. The whole thing can feel like this completely opaque black box.
And that is exactly where observability comes in. Now, you can find the textbook definition right here, understanding internal states from external outputs. But what does that really mean for those of us on the ground? Well, it means having the power to ask brand new questions about your system, questions you didn't even think of when you built it, and getting clear answers back. It's all about shifting from "I think I know what's wrong" to "I can see exactly what's wrong."
So, here's our game plan for today. We're going to break down observability into its three core pillars: metrics, logs, and tracing. Then we'll look at how a standard called OpenTelemetry ties them all together. And finally, we'll talk about how this all works in the real world, because it's a huge team effort. Let's get into it.
First step, let's talk about Pillar 1, metrics. I want you to think of this as the absolute foundation for understanding the health of your system.
At their core, metrics are all about answering one simple question: what happened? They're numerical measurements, usually collected over time, that give you that high-level quantitative view of your system's performance.
Think about the fundamental health checks, like CPU and memory usage, or how much disk space is left on your servers. But metrics go way beyond that. They track application performance too. They answer questions like, what's our API success rate looking like? How about our failure rate? What's our average request latency? This historical data is absolutely crucial for spotting trends, and of course, for setting up alerts that tell you when things are starting to go sideways.
And look, when you hear metrics in the cloud-native world, you're almost always going to hear Prometheus in the same sentence. It's pretty much the de facto open-source standard for collecting and storing all this time series data. It lets you query it and build all those cool dashboards to visualize what's happening.
Okay, so metrics tell us the what, but they don't always explain the why. For that, we need a lot more context. And that brings us right to our second pillar, logs.
Right, so if a metric tells you that your API failure rate suddenly spiked to 10%, a log is what's going to tell you why. Logs are these individual, time-stamped events that give you incredibly detailed, contextual information about what your application was doing at a very specific point in time.
And a useful log isn't just some random print statement somebody left in the code. No way. It's a structured event. It's got a timestamp, a severity level, like info, debug, or error, and a message that gives you real context. A good error log, for example, might have the exact error message, a user ID, a request ID, basically a rich trail of breadcrumbs for you to follow. Now, in a distributed system, you could have thousands of log streams pouring in from all your microservices. It's a flood of data. The EFK stack is an absolute powerhouse for taming this chaos. You've got FluentBit, which is a super lightweight agent that collects logs. It sends them off to Elasticsearch, a powerful search engine for storing them. And then you have Kibana, which gives you that nice UI to search, filter, and visualize all that data in one spot.
All right, so we have the what from metrics and the why from logs. But in a microservices world, that's still not the whole story. We need to understand the full journey of a request, from start to finish. And this brings us to our final pillar, tracing.
Tracing answers the big questions. How did a request actually flow through my system? And, maybe more importantly, where is the bottleneck or the failure? It literally follows a single request from the moment it hits your system through every single service it touches, all the way until a response is sent back to the user.
The best way to think about tracing is with a simple travel analogy. Let's say you're flying somewhere. You don't just magically appear in Boston, right? You have an itinerary. You go from your house to the airport, then you fly to a layover, say in Dubai, and then you fly to Boston. Each one of those steps is a distinct part of the journey.
And this maps perfectly to what happens with a user request in our systems. It hits the load balancer, then it's routed to a login service, then maybe a payment service, and on and on. A distributed trace shows you each of these hops, and, this is the key part, it measures the time spent at each one. This is how you find out that a request that should take 50 milliseconds is actually spending 2 whole seconds stuck inside that payment service.
So to actually see these complex journeys, we use tools like Jaeger. It's a fantastic open source project that takes all that trace data and shows it to you as a waterfall graph. It makes the path and the timing super clear, which makes finding those hidden latency problems so much easier.
So, we've got Prometheus for metrics, EFK for logs, Jaeger for traces. That's a lot of different tools to manage. How do we get our applications to talk to all of them without getting locked into a specific vendor or having to rewrite our code all the time?
The answer is OpenTelemetry, or OTel for short. And honestly, this is a total game changer. It's a single open standard, basically a set of APIs and SDKs, that your developers can use to instrument their code just one time. After that, you can configure the OTel agent to send that data to Prometheus, to Jaeger, to Datadog, to whatever backend you want, all without changing a single line of application code. It's all about freedom and portability.
Okay, having all the right tools and standards, that's only half the battle. To make observability really work, we have to talk about how it works in practice, and more specifically, whose job is it anyway?
And the answer is, it's a true partnership. Developers are really on the hook for instrumentation. They're the ones inside the code, so they need to be the ones adding the libraries to send out custom metrics, writing those meaningful structured logs, and making sure that trace information gets passed from one service to the next. Then you have the DevOps and SRE teams, and they're responsible for the implementation, setting up, configuring, and maintaining all the back-end platforms that collect, store, and visualize all of that powerful data.
And this really hits the nail on the head. It's the key takeaway. You just can't have one without the other. An SRE can build the most amazing Prometheus cluster in the world, but if developers aren't instrumenting their apps to send data to it, it's completely useless. It really is a collective effort.
So, why do we go through all this trouble? The ultimate goal here is to change the entire culture. It's about moving away from reactive firefighting and towards proactive, data-driven improvement. When you can understand your system this deeply, you can find and fix problems before they impact your customers and before you break those SLAs, the critical promises you've made about your service's reliability.
So, to wrap this all up, I want to leave you with one final thought to take back to your own teams. With everything we've talked about, think about your biggest blind spots. What's the one question about how your system behaves under pressure that you just can't answer right now? Because I'll bet the path to figuring that out lies in improving your observability. Thanks for tuning in.